Throughout the course, we're going to look at two ways of going through the life cycle development, plan-driven or agile. So the plan-driven processes are all the process and activities are planned in advance and progress is measured against this plan. In agile processes, planning is actually incremental and it's easier to change the process to reflect changing customer requirements. In practice, most practical processes include elements of both plan-driven and agile approaches. It's really important to understand this, that there are no right or wrong software processes. The only time it can be right or wrong is if you apply the wrong type of process to the wrong project, or to one particular project. So, the plan-driven process in software engineering, for instance, is often quoted as being a traditional approach. It's quite a heavy approach, like waterfall, spiral. But let's look at when we use agile and when we use plan-driven. So, agile process is used if the project has unpredictable or dynamic requirements, so things change all the time, and it needs responsible and motivated developers and customers who understand the process and who want to get involved. Whereas a plan-driven one is when requirements are very well known, the product definition is stable, the technology is understood. It's often used for new versions of an existing product or porting an existing product to a new platform. The MOD used to use plan-driven. I don't know whether they still do, but it was one of the things that they had to use. They knew their requirements. Everything was absolutely regimented. Let's have a quick look at software development process models. This basically is the approach one takes to the life cycle. And within that, you have whether you take an agile approach or a plan-driven approach. But it's the way the life cycle will work. So the main ones are waterfall, spiral, V-shaped, iterative and incremental, reuse, agile. So the waterfall model is a plan-driven model, separate distinct phases of specification and development. Incremental development, specification, development and validation are interleaved. This actually may be plan-driven or agile. Reuse-orientated software engineering. The system is assembled from existing components, may be plan-driven or agile. In practice, most large systems are developed using a process that incorporates elements from all these models. Software process models. We're going to look at different types of software process models. For instance, the waterfall model, that's a plan-driven model. It's separate and distinct phases of specification and development. The incremental development model has specification, development and the validation. They're all interleaved. This actually may be plan-driven or agile. We then have reuse-orientated software engineering model. The system here is assembled from existing components, and this may be plan-driven or agile. In practice, most large systems are developed using a process that incorporates elements from all these models. Let's have a look at the waterfall model problems. It's a bit inflexible. Partitioning of the project into distinct stages make it difficult to respond to changing customer requirements. So this model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. Few business systems have stable requirements. Critical systems may have stable requirements. They're systems that are not going to change. You have to do it a certain way. You have to have it that way. So waterfall might be good for that. The waterfall model is mostly used for large systems engineering projects where a system is developed at several sites. So in those circumstances, the plan-driven nature of the waterfall model helps coordinate the work. The main drawback of the waterfall model is the difficulty of accommodating change after the process is underway. In principle, a phase has to be completed before moving on to the next phase. Though some people actually use the waterfall model slightly differently. They will use those kind of stages and then go back, but that's not really true waterfall. In, for instance, a project where you have different people doing different roles, you have the analyst, they analyse something, the requirements, and then it's given to somebody else, then that's when waterfall will be used. So if you've got people developing things at different sites and different roles being in different sites. We described incremental as being interleaved, so let's have a look at what incremental benefits are. The cost of accommodating changing customer requirements is reduced, so the amount of analysis and documentation that has to be redone is much less than is required with a waterfall model. Waterfall model has a lot of documentation involved at each stage because somebody else is going to do the next bit probably. It's also easier in the incremental to get customer feedback on the development work that is being done. So you do little bits at a time, so you can say, oh, have a look. And customers can comment on demonstrations of the software and see how much has been implemented. There's also more rapid delivery and deployment of useful software to the customer is possible in this instance. So customers are able to use and gain value from the software earlier than is possible with a waterfall process because it'll be done much quicker. However, it doesn't mean to say that incremental is the answer to everything because that has its problems as well. For instance, the process is not visible. That means managers need regular deliverables to measure progress. And if systems are developed quickly, you can't produce documents that reflect every version of the system, so they don't always know what's going on. System structure tends to degrade as new increments are added, so unless time and money is spent on refactoring, that's changing existing code without changing the behaviour, then regular changes tends to corrupt its structure. Incorporating further software changes becomes increasingly difficult and costly. So you can see that both have their pros and cons. Orientated software engineering really is where you go from requirement specification, components analysis, requirements modification. So you're actually modifying things, you do system design with reuse, you develop and integrate, and you validate the system. This basically is reusing something, adapting something. So for you gamers out there, if you're modding, that's what you're actually doing. You're doing reuse-orientated software engineering. So you're not changing everything, you're just changing bits of it. And you're modifying the requirements, you're reusing what's already there. The spiral model has been very influential in helping people think about iteration in software processes, and it introduced really the risk-driven approach to development, and that's still used, so you go round and round. Agile development, that's more adaptable than plan-driven ones, and in a way it's what's been done with spiral iterative style models for years. Even though they may not have called it agile, that's actually what we used to do. The difference is that it has less formal structure and is far more adaptive. So in the first semester we're going to cover stages of systems analysis and design rather than just the full life cycle. We're looking at analysis and design. So in the feasibility definition stage, which is our initial analysis, we're going to look at, is it possible to do? Do we have the technology and resources? And then you put a plan together. What methodology am I going to use? What am I going to do? In the analysis and definition, which is our full analysis, you're going to look at the current system, whether it's manual or computerised, understand the requirements, understand the business needs. In the design stage, we're going to look at how to design new solutions for software and hardware, how to model the design. Within this, we're going to use processes, tools, techniques, manage projects. You'll validate, evolve by interacting with stakeholders. And in a real project, you have to ensure you're on budget, on time, and that it's of quality. Okay, so how does all this systems analysis and design actually really fit into the software development lifecycle? Well, software development follows three basic generic phases regardless of which model, paradigm or methodology is chosen. So we're going to either do plan-driven or agile or combined approaches. But the three phases always included in whatever process or approach we take within the life cycle are definition, development and maintenance. It's basically about the process from inception to completion and through to evolution. So let's recap. Definition, specification, that focuses on what? What are we going to do? What do we need to know about the business? What do they want? The development focuses on how. That's the design and implement phases. So, how are we actually going to design this? What's the best solution? How are we going to code it? How are we going to test it? The maintenance, evolution focuses on change. Does it need changing? Does it need to be tweaked? And it may be in future that you need to add on things. So when you are designing and implementing, you need to consider, are they going to want to change something in the future? It's got to be future proof. And added to these are verification and validation, which is really important. Have we built it right? And have we actually built what was required? We're going to look at this later to see why it's important, verification and validation, in how systems fail and why systems fail. Lecture 2C follows this lecture, which is all about methodology, and it brings together the software development lifecycle and the process model and introduces the aspects of methodology. Please ensure that you actually have a look at this because it is an important aspect.